Hi, everyone, and thank you for joining us today for this webinar. Jason Allen here, the Concrete Pipe Guy. I am the Technical Resource Engineer for Oldcastle Infrastructure, and I will be presenting today's webinar. And our topic today is Post-Installation Inspection Fundamentals. So before we begin, I want to tell you a little bit about myself. I currently live in Utah. I'm a proud University of Utah graduate with bachelor's and master's degrees in civil engineering. I've been in the engineering industry for over 20 years. When I was 18 years old, started working as a surveyor and then transitioned and moved into drafting, design, and land development. I worked in the public sector as a county engineer and a public works director. I've also done consulting engineering work in roadway and drainage design for the Department of Transportation and large municipal projects. And now I am a marketing engineer, or the technical resource engineer for Oldcastle Infrastructure. So some of you may not be familiar with Oldcastle Infrastructure, so I'll quickly share some of the solutions that we can provide. Now, as I mentioned before, I currently live in Utah, and I spend a majority of my time in Utah and Idaho providing technical resources to design engineers, contractors, and inspectors. And most people know us by our precast products, mainly reinforced concrete pipe and precast box culverts, but we also provide precast manholes, catch basins. And while this has been our main focus for a lot of years, we have recently added some really cool new product lines to help meet your needs. Oldcastle recently acquired Torrent Resources, a company out of California that is the industry leader in drywall manufacturing and installation. We also expanded our stormwater solutions to include storm capture, a total stormwater management system that uses precast sections for underground detention storage. And this system uses the strength of reinforced concrete to provide more volume for storage, which drastically reduces the footprint area compared to other underground detention system options. We've also have multiple stormwater treatment system options like sediment traps, hydrodynamic separators, and these can help fit your specific needs and stormwater treatment requirements. Now, our newest addition in the Utah market is gasketed box culvert. And now, instead of the typical soil-tight mastic joints, we now have the ability to manufacture gasketed box culverts to provide a watertight joint without any additional joint treatment, which saves time and money on installation. Now, in previous webinars, we have discussed the differences between rigid and flexible pipe related to pipe design and pipe installation. So today, we will discuss a way that owners can ensure that their pipe systems were designed and installed correctly, post-installation inspection. So let's jump right in. Okay, so these are the three main areas that we're going to focus on today in this webinar. We're going to give a brief overview of installation, and then we're going to talk a little bit about cracks and deflection. And then lastly, we're going to talk about post-installation inspection and what some of our recommendations are for those. So let's jump into installation here. Now, the bottom line is that buried pipe must perform two very critical functions. We know that it has to act as a conduit to get either stormwater, wastewater, whatever it is, from point A to point B. It has to be a conduit to carry that material. The next thing it has to do is it has to act as a structure. So we want to make sure that these pipe systems are doing both of these functions, acting as a conduit and also acting as a structure to withstand the loads that are put on top of this pipe. So when we look at two different soil pipe systems here, we've got flexible pipe on the left and rigid pipe on the right. Now, flexible pipe obviously would be your plastic pipes and your metal pipes, and rigid pipe would be your reinforced concrete pipes. So with flexible pipe, the embedment soil is the thing that must carry the most of the load. Because when we have a flexible pipe in the middle, watch what happens as we load that pipe. As we load it, the pipe itself wants to deflect outward. So it's very critical that we have stiff columns installed on the side of that pipe. So you can see that gray area around it is the whole pipe zone, and that we're installing and we're creating that stiff column on the side of the pipe to keep it from wanting to bend or deflect outward. Okay, now with rigid pipe, it's a little bit different because the pipe itself carries the majority of the load in this situation. So the pipe is stiff, so it's allowed to have a little bit more flexible embedment soil on the sides of the pipe. So if you notice, the pipe zone and the structural element of this pipe is the pipe itself and only up to about the spring line of the pipe. So you could just do typical backfill around the top of the pipe there, unlike your flexible system. So when we load that stiff element there, that rigid pipe, it can be a little bit more flexible on the side, and it won't affect the structural capacity of that pipe. So let's just look at a little comparison here between rigid and flexible. This is kind of a real quick summary of what we discussed the last couple of webinars. So on the left-hand side, I'm going to present a feature, and then on the middle, we're going to talk about rigid pipe and what it means for rigid pipe, and then on the right-hand side, what it means for flexible pipe. So the first is we're going to talk about what the characteristic is of the pipe. Now, for a rigid pipe, the characteristic is it acts as a structure itself, and for a flexible pipe, it acts as a liner. Okay, so rigid is the structure. The flexible pipe is the liner. All right. The pipe zone in both of these, in rigid pipe, it is from the bedding to the spring line. That is the pipe zone. And in flexible pipe, it is to approximately 12 inches above the pipe minimum. Some sizes of pipe and some installation methods maybe require more cover on top of the pipe for that pipe zone. But generally speaking, the pipe zone would be the bedding to spring line for a rigid pipe or RCP, and to about 12 inches above the pipe for flexible, whether that's plastic or metal pipe. Okay. Lift thickness for rigid pipe, there's really no specification there. It's just what it is to get your compaction and your percentage compaction there, based on what we talked about in the previous couple of webinars on how to achieve that. Now, with flexible pipe, the recommendation is from manufacturers is 4 to 6 inches of uncompacted lifts. So if you've got a 24-inch pipe, you're going to have a lot of lifts to get to that 4 to 6 inches of uncompacted and then compacted down. You're looking at anywhere from, to get from the bedding to the top of the pipe, you're looking anywhere from 9 to 12 lifts to make sure that we're getting that compaction correctly in flexible pipe. All right, the structure itself here in the rigid pipe, it is created in the plant. Right? We manufacture this pipe to be a structure. We take care of the structure in the plant and we deliver it to the site. With flexible pipe, the structure is created in the field, right? And it's imperative that it's designed correctly and installed correctly to ensure that that structure is being built in the field. Now, the design, who's responsible for the design? In rigid pipe, we know that the manufacturer is responsible to provide that structure and to design it and make sure that it will meet the loads. With flexible pipe, it is the project engineer who is responsible to do the structural design. Okay, so that's a quick, really down and dirty summary of installation and the differences between rigid and flexible pipe. Now, we know that they're different. We know that rigid and flexible pipe are different. They should be designed differently. They should be installed differently. So let's talk about the differences between these as it relates to what we know is going to happen with both of these pipes. So these are the things that we know. Number one, we know that concrete cracks. Right? We have accepted that. We know that we've been using it for centuries, for thousands of years. We know that concrete is going to crack. We also know it's going to last a long time. We know that flexible pipe, whether that's a metal pipe or a plastic pipe, we know that it's going to deflect, right? It's going to change. As we load it on the top, it's going to want to bend outward and deflect outward, and it's going to want to squish a little bit. We know that those things are going to happen. So what we have to look at is we need to say what is acceptable. Okay, if we know that concrete pipe is going to crack, and we know that just like sidewalks, curb gutter, any of these things, we know it's going to crack. That's why we put in joints every so often. We put in expansion joints and things because we know that it's going to crack. We want to make sure that we're minimizing that as much as possible. So we have to look at what is acceptable with regards to cracks and with deflection. Okay, so let's talk about cracks. We'll start with cracks. What are acceptable cracks? So there is a national specification. It's ASTM C76. This is the manufacturing specification that we follow to make sure that we're making this pipe correctly. Per ASTM C76, a 100th inch crack is acceptable. And the definition in that specification of what a 100th inch crack is that it is at least 12 inches long. So if it's just a real short crack for 6 inches or so, that doesn't even qualify as a 100th of an inch. So it's even smaller than that. So it has to be at least 12 inches long, and it has to be a 1/4 of an inch deep. You've got to be able to stick a 100th of an inch feeler gauge into that crack 1/4 of an inch. So if you can't get it in at all, then we know it's less than 100th of an inch, and that is an acceptable crack. Okay. Now, this is referenced, this ASTM C76 is referenced in a lot of local DOT specs and regional specs. The ones that we deal with in Utah would be UDOT and the Idaho Transportation Department. And our regional specs that we deal with are, there's one that a lot of municipalities use called the Utah APWA spec. And in Idaho, we see a lot of them using the ISPWC, or the Idaho Standards for Public Works Construction. Now, in a later webinar that I'll be doing at a future date, I'm going to talk more about what these national specs say, what the regional and local specs, what some of our DOT specs say. So we'll get more into that on what is acceptable with regards to those specs. So I'm not going to belabor the point too much today and get too into the weeds with it. But just know that this spec is referenced in there. And so Almost every single spec that I've read has referenced ASTM C76, and it refers to these as hairline cracks. Okay, so anything hundredth of an inch or smaller, these are hairline cracks. Anything over a hundredth of an inch, typically you want to evaluate, have an engineer look at that and evaluate it. Now, I want to show you what that kind of looks like, what a hairline crack looks like. This is a crack that was in a pipe that when they went and did the CCTV video, when they were looking at it and determining what cracks were acceptable or not, the owner said that crack looks really, really big. What happened was they zoomed in really far. It looked bigger than it really was. They pulled the pipe out of the ground. They made us remove it. And this was done, this was probably 10 years ago. So for reference, there's a business card there that you could see that shows the size of this crack. It is very minor. This is hairline. You definitely wouldn't be able to get a quarter of an inch deep with a feeler gauge into that. So we know that pipe, that crack should have been acceptable. We shouldn't have removed that. It caused a lot more work to remove and replace that section of pipe, but the owner asked us to do that, and as we pulled it out, we evaluated and noticed it really should not have been removed. This was an acceptable crack. It was within the specifications and the acceptable limits. Now you might say, well, what about the chipped bell there, that issue there at the joint? That was actually done as we were removing it, so we caused more damage to the pipe removing it and discarding it than we did when we put it in the ground. So that came after as we were removing it. But the what I wanted to point out itself was how small that crack is, and sometimes in a video it can look really big. So we don't want to do more work or more damage to the pipe system by removing a pipe that actually meets the acceptable standards there. So you might be asking yourself, how big is 1/100th of an inch? How big is that? So I want you to imagine a dime. Okay, take a dime, pretty thin, that dime there. Now a dime, if you measure the thickness of a dime, if you lay it down flat and you measure that thickness, it is 0.05 or 5/100ths of an inch. Okay, so it's 5/100ths of an inch. So if you were to cut a dime into fifths, that would be 1/100th of an inch. So anything less than that, those hairline cracks, that is acceptable. Okay, so 5/100ths of an inch or less, or 1/100th of an inch or less is a hairline that's acceptable. And there's other limits that we could talk about with some of these other specifications with cracks. So now acceptable deflection. Let's talk deflection real fast. So typically, we've got one that's with Utah APWA. This is now typically, I should say that 5% is typical for acceptance. Now in Utah APWA, this is one that most of our municipalities use and reference. Okay, this is for HDPE and polypropylene, so plastic pipes. 5% maximum deflection is what is allowed. For corrugated metal pipe, they allow up to 7.5% max. So if you have a 24-inch pipe, okay, 5% deflection would be 1.2 inches of deflection. So that the change in the internal diameter would be 1.2 inches on a 24-inch pipe. For CMP, it would be about 1.8 inches on a 24-inch pipe. Okay. Now, UDOT, the one that we use here in Utah, the Department of Transportation, they say that any deflection less than 5% is acceptable. Anything between 5 and 7.5% you should evaluate, and anything over 7.5% you should reject or remove and replace. And the reason is because we have this issue with ring compression and arching. Now, when a pipe is perfectly round, you have, as you load it top and bottom, the load is distributed around in what we call ring compression. So it's all working together as a ring to distribute those loads around it, and it works together in harmony to make sure that we're in this ring compression. Once we deflect to a certain point, the structural capacity of that pipe starts behaving more as an arch than it does a ring. And so once we get into the arching, right, you now are decreasing the ability to withstand the loads. The more it arches, the more it bends, the more likely it is that that pipe will fail. So that's something we want to keep in mind. Okay, so we have some skeptics in our market, some of the engineers and inspectors that we talk to. So they'll say, well, now wait a second, let's go back to cracks. Let's talk about this. Why would any cracks be acceptable? We've had municipalities, we've had owners say to us, hey, we don't want any cracks in our pipe because we want this to be perfect. We want it to function correctly as we want it. Now, just because a pipe has cracks in it doesn't necessarily mean that it won't function the way it's supposed to, right? Not all cracks are equal, and so we need to look at it and evaluate. But let's talk real fast why any cracks would be acceptable. All right. So when we do that, we have to look at this in the frame of what are the effects of cracks. First of all, a crack could restrict the function of the pipe. So we've got to look at it from a functional standpoint here of what is this pipe, what are we trying to accomplish, and what is it trying to do? So if you look at, say, let's say storm drain pipe. Okay, we'll take that for example. The function of the storm drain pipe is to collect in the catch basin. We collect the storm water, the surface water from the storm. It goes into the pipe. The function of that pipe is to get that storm water from point A to point B, right? So we need to say, is this crack, or would this crack affect the function of being able to get the water from point A to point B? Some larger cracks may cause the water to actually percolate out of the pipe and into the groundwater. Maybe we don't want that, especially if it's a wastewater pipe. We don't want that to happen, obviously. But if it's a storm drain, maybe a little bit of percolation is okay. Sometimes if it's high groundwater areas, we don't want that groundwater infiltrating into our pipe. So we have to say, will this crack or will this issue with the pipe, will it cause a problem and cause this water to come into the pipe? So those are things we need to look at functionally. How would this crack affect the ability of this pipe to serve its function? The other element that we need to look at is structural. Is this crack severe enough that it's causing structural damage? Is it exposing the steel? Is it damaging the steel? Is the crack wide enough and deep enough that it's going to cause the steel to corrode over time? These are things that we need to look at with the structural part of it. What caused this crack? Was it from structural loading, and now it's not going to withstand as much load because we've already overloaded it and we've caused it to crack beyond ultimate? These are things that we need to look at as we evaluate cracks from a functional standpoint and a structural standpoint. Okay. So there is a phenomenon in concrete known as autogenous healing. Now, autogenous healing is the ability of concrete to heal itself in the presence of moisture. And what this does is it actually seals the crack itself. Now, okay, Mr. Skeptic comes back and gives me the side eye and says, now, wait a second. You're telling me that concrete can actually heal itself and it will seal any cracks? And I say, well, maybe not any crack. On larger cracks, it's possible that it will not heal, but yeah, on smaller cracks, anything up to about 0.05 of an inch, this autogenous healing will take place. All right. So for the skeptics out there, let me share with you the science behind autogenous healing. Let's talk about this. So in cement, okay, we have free calcium oxide within the cement itself. Okay, now as tricalcium silicate, which is another component of cement, as it is hydrated, okay, so as the cement mixes with the water and it becomes hydrated in a concrete mix, okay, the calcium hydroxide is liberated, okay? So as I mentioned before, that is as we hydrate this and as it comes in contact with water. Now, one thing we also know is that there is carbon dioxide in air, in the soil, in the water. There's carbon dioxide, trace amounts of carbon dioxide everywhere. Now, what happens is this carbon dioxide is absorbed by the concrete in the pipe. Okay, so the concrete pipe actually absorbs and reduces the amount of carbon dioxide in the surrounding air, soil, and water. And what it does, it's this fascinating phenomenon where it actually carbonates. The carbon dioxide carbonates the calcium oxide and the calcium hydroxide. And what it results in is it creates a calcium carbonate crystal or limestone, right? So it creates this limestone and it actually seals in the crack. Okay, so I know there's some people out there that are chemistry nerds like me. I love chemistry. I'm fascinated by it. So I'm going to share with you the autogenous healing reaction formula. So this is the formula here. So this is, as we could tell, this is the calcium hydroxide. When it combines with the carbon dioxide, right? The resultant in the formula is we've got this calcium carbonate, the CaCO3, and water. Okay, that is what results in this chemical formula. So this is a picture of a pipe where you're actually seeing the autogenous healing happen. You may have seen this and noticed this in other things, like in a sidewalk after it's been raining for a while, or if you watered your lawn, you may see a crack in the sidewalk or a curb and gutter or any concrete, really the base in your foundation. A hairline crack, you may see this white effervescent material. And this is actually the calcium carbonate, which crystallizes and seals in that crack. Okay. All right. Oh, geez. Mr. Skeptic's back. All right. I know you've still got questions, Mr. Skeptic. What do you want to know this time? How long does this process take? That is a very common question that we get. We say, does it happen overnight? We want to make sure that we're not losing too much water if it cracks, right? We want to know how long does this autogenous healing process take? Well, I'm gonna let you in on a little secret here. Mr. Skeptic here was me. Actually, I had a lot of these questions when I became the Mountain States Concrete Pipe Association director, and I was learning a lot about the behaviors of concrete pipe and all of these different things. Someone shared with me this autogenous healing concept, and I was fascinated by it. And I was a little I not only fascinated, but I was a little confused on things, and there were a lot of questions that I had. Right. So I was really curious about some of these things. So I asked this question: how long does this process take? I was a little cynical, right? I didn't know if it would really work. So I wanted to see it in action. So what I did when I was the Mountain States director was I decided with some of our plants in the Utah market, we were going to do an experiment. Okay. So this is an experiment that we did when I was the director of the Mountain States Concrete Pipe Association back. This would have been about 2018 is when we did this experiment. So what we did was we took a 24-inch class 3 pipe and we loaded it to ultimate load, and then we released it to produce the cracks. So basically ultimate load would take this to about 0.05 of an inch to 1/10 of an inch. So well beyond what the acceptable crack limits are based on the ASTM C76 spec. So we loaded it, got it to about 0.05 of an inch. We were able to stick a dime in that crack pretty easily, so we know it was a really big, thick crack. And what we did was we then sealed the bottom, we cut the pipe in half, so we had the same pipe, so it had the same crack. It was a homogeneous crack all the way across it. And then we sealed the bottom of it. We poured concrete in the bottom of both sections of pipe. So on one half, we poured it on the bottom, and we filled it up with water. And then on the other half, we filled up the bottom. We sealed it with concrete, and then we waited. So one we filled with water for about 3 weeks, let it sit and stand. And then the next one we did that morning of when we had people come in and tour our plant, some of our inspectors and engineers. And what was interesting is if you look at this pipe, this is the 2 pipe specimens here that we have. The one that's closest to view, you can actually see where the water has been coming out, and you can see that white effervescent material after 3 weeks is already coming into play and sealing up that crack, right? You could tell the one next to it that's been cracked. You could see that that water is running. It's coming out of that pipe, and it is running out, and there's no white effervescence. So in one day, you've got a lot coming out of the far pipe, and then the water is already starting to seal and slow down in the close pipe. So the difference between the two, I'll kind of tell you what I noticed as I filled it up and I was measuring throughout the day. The pipe that's closest to us that had been filled with water for 3 weeks and had already started healing, right? We were filling it up multiple times a day to make sure that we kept the water to the top so that it would heal all the way through the pipe. The pipe that had been healed for 3 weeks was leaking water at a rate of approximately 1 inch for every 2 hours. Okay. So it was still leaking. So it hadn't fully healed after 3 weeks, but it was leaking pretty slowly, 1 inch every 2 hours. The pipe that we filled up the morning of, it was leaking at a rate of 2 inches every minute when we first filled it up. And by the end of the day, it was still leaking at a rate of about 1 inch a minute. So it was leaking out. And you can also see, if you look on the right-hand side of that pipe in the far pipe, you could see that not only is it leaking out of the front where the main crack is, but there's also cracking on the side of the pipe that's leaking. But in the pipe, the larger pipe, that's all dried out and it's completely healed on that side. So we looked at these again after about 3 months. And after 3 months, the pipe in the foreground was completely healed. It wasn't leaking at all. And then the other one had minor leaking at it. But after about 3 months, of being completely filled and submerged with water, the pipe itself was completely healed and it wasn't leaking anymore. So that answered that question on how long does this process take? Okay. So as I mentioned before, I was Mr. Skeptical. So I still had some questions. All right. We answered the question through my experiment. We answered the question of how long does this take, and does it actually work? Does it seal the pipe? But the fact remains that the pipe has been cracked. And my question was, would this affect the overall pipe strength? So I started thinking about it. Okay, we have a crack. Is it going to make the pipe weaker? Is it going to cause it to crack? If it cracks again, will it crack in the same location? What does this do? What is the effect on pipe strength? So I decided I solved it one way doing an experiment. So we're going to do another experiment. Our American Concrete Pipe Association asked us to do this experiment, and we did it in our Oldcastle Infrastructure plant in Ogden, Utah. So we did a similar experiment where we cracked a pipe, and we wanted to see what would happen if we cracked it, healed it, and then cracked it again. So this is a short video that I'm going to play for you now that will explain what we found.
One question the American Concrete Pipe Association often hears is, why is minor cracking in concrete pipes okay? The answer is found in the principle of autogenous healing. Autogenous healing is concrete's ability to heal itself in the presence of moisture. The visual indication of autogenous healing is a whitish substance known as calcium carbonate. The American Concrete Pipe Association demonstrates the principle of autogenous healing in a test that shows calcium carbonate sealing a pipe's minor cracks after 3 days of the pipe being filled with water. Loads were tested, and the cracked but healed pipe had gained an additional 23% strength after 1 month. Our results provide positive anecdotal evidence of autogenous healing's speed and strength, and evidence that minor cracking poses no threat to the soundness of concrete pipes.
So it's interesting to note that when it cracked again, it did not crack in the same location. That was the first thing I observed and was interested in. And it made sense that as the pipe continues to heal and as it continues to age, we know that concrete continues to get stronger over time, and the longer it cures, the stronger it's going to be. So we would naturally expect the pipe to be stronger if we tested it later. But it was fascinating that it cracked at a different location, and it did not affect the overall strength of the pipe. In fact, we were able to withstand even more load, and it made the pipe stronger over time. So when we have these cracks, right, we know that some are acceptable, but we may need to look at what are some repair options, right? We don't always want to rip up a pipe and replace it if it's in the ground. If we can repair it, we want to look at that. So for anything that's 1/100 of an inch or smaller, there's really no repair necessary. So when we look at larger cracks, anything, we mentioned that autogenous healing happens. We saw it, we noticed it, that it did it in about 5/100 of an inch. In some cases, it might be able to even heal up to 1/10 of an inch. So anything, between 5/100 of an inch and larger, we may want to evaluate, but definitely anything over 1/10 of an inch, we want to look at what we need to do to solve that. So some of our options are injection grouting. If the crack goes all the way through the pipe, you may want to injection grout to seal it. That would protect the steel. It would seal that crack. It's basically doing the same thing that autogenous healing is doing, but it's doing it faster to seal that crack and make sure that it's not causing any long-term damage or any issue to the pipe functionally or structurally. Another option would be a grout sleeve, which is where you go and put a steel sleeve in there and you inflate it and you grout it, you pump it with grout, and it acts as more of a structural solution in areas where you may need to provide a little bit more structural strength. And then there's also a very expensive option is to line the pipe. We've had that where it's been major issues after a pipe's in the ground and it's been installed, and then a contractor comes in and drives over the pipe without enough, without adequate cover over it, and they've got heavy construction equipment coming in. Sometimes it can cause enough significant damage that you might need to use a liner or even remove and replace the pipe if it's either a really, really poor installation and has major issues, or if it may have been a perfectly good installation, but a contractor after the fact comes in with fully loaded trucks and they didn't put the correct amount of fill on top of it during construction to protect it, and it might cause damage. So we've seen that as well. That could be an option there. Okay. So when we look at deflection, let's, compare that with deflection, what some of the repair options are with cracking. But what about deflection? Are there any repair options for deflection? And really the only option that really works is to remove the section of pipe that's deflected and replace, because as we mentioned before, there's really nothing you can do to structurally stabilize that once it goes from ring compression to that arching, right? We're starting to really affect the structural component of that pipe now. So once you see a major issue where it's affecting the structure of the pipe, we need to fix that and remove and replace. And so there's really no good way to get it back once it's deflected past the maximum allowed deflection point. There's really no way to get that structural component back. Now, the interesting thing about this is when we're removing and replacing, it's typically under the roadway. So at the point where we pull the mandrel through and we do a deflection test, you're typically well beyond 30 days is the recommendation that you're supposed to be doing this this test, this inspection, this post-installation inspection at, after 30 days after the pipe's been in the ground, and 30 days after a storm drain pipe's been in the ground. You've usually paved and put your curb gutter, sidewalk, and everything in. So this could have major issues on cost and time for the project if you have to remove and replace a section of pipe. So it's really important that we install it correctly. Okay. All right. So that's cracks and deflection. Let's look at our last section here that we were going to talk about, and that is the actual inspection itself, the post-installation inspection. So I've had a lot of inspectors and engineers and even contractors ask me, why do we need post-installation inspection? What's really the benefit? Why do we need that? So some of the benefits are, first, it ensures that the pipe meets the standards, right? We put so much time and effort into putting our construction drawings and our standards together. And then we want to make sure that it has been installed correctly and that it meets our standards. And for the owners and the end user, this is a way that we can protect our investment. We want to make sure that it was installed correctly and that it's going to last, right? And it's really just, lastly, an accountability check for the installation. So as the installer comes in and does his job, we want to know, did they install it correctly? Was it installed in line, in grade? Did they put the right structural components around the flexible pipe so that it doesn't deflect? Did they do that correctly? Did they dig the bell holes for concrete pipe correctly? Did they, different questions that really are telling when we go in and do our post-installation inspection. We could tell a lot about how that pipe was installed. So this is a good accountability check for the contractors. Now, some of you may know that I am a big fan of baseball, and this is a point that I will argue a lot. And so I found a good picture of a coach arguing with an umpire here. But this is a point that I always want to point out here. Post-installation inspection is not meant to replace inspection during installation. We still want to make sure that we've got inspectors out on the site ensuring that the pipe is being installed correctly, that the pipe's being homed correctly, that it's being backfilled correctly, that it's being bedded properly. We want to make sure that this is being done during construction. Post-installation inspection is not a replacement for that, right? We still want to have inspectors out on the job site. PII, or post-installation inspection, is just a safeguard and a secondary thing that we could put in to make sure that if there's something that our inspector missed something out in the field or was gone or had to run to another meeting or something, we want to make sure that sections of pipe weren't installed incorrectly. And post-installation inspection is a very good way to ensure that. So there's a couple of different methods that we'll talk about. So with concrete pipe or rigid pipe, right, we want to use CCTV, because what are we looking for? We're looking for cracks. We're looking for issues at the joints. We're looking for these things. Those are things that can show up on a CCTV inspection as they put this remote controlled this remote control device in there with a camera on it. It's going to go through and it's going to check all of the pipes. Now with flexible pipe, whether it's corrugated metal, whether it's plastic pipe, but mostly smooth line plastic, you're going to want to do two things. You're going to want to do CCTV and deflection testing with the mandrel. If it's a smaller diameter, if it's a large diameter, you may have to go in by hand and take hand measurements for the deflection test. But you want to do both, and there's a reason that we want to do both on that, and I'll get into that in just a moment, okay? So let's talk about the recommendations for CCTV, okay? We want to make sure that we're getting the best inspection possible. So let's look at what that means. All right. So one of the recommendations that I've tried to get people to write into their specifications is that any post-installation inspection videos that are done with CCTV, that the person operating the machinery is NASCO PACP certified. So NASCO is the National Association of Sewer Service Companies, and PACP is their Pipeline Assessment Certification Program. We want to make sure that whoever is doing this is PACP certified. I've taken the course with NASCO. I am PACP certified, And so it was really interesting to me and really telling. And as I mentioned before, we're going to talk about some of the national specs in a future webinar. I'm going to get more in depth into what the PACP coding and certification is, and we'll talk about that at a future webinar. So once we know that they're PACP certified, one of the recommendations is that we center the camera in the pipe. This is something that NASCO recommends, but it's always good to make sure that as they go in there, that the camera is centered in the pipe. When they're using these different fisheye lenses to get the view, if it is not centered, if it's too far down, as they look down at the bottom of the pipe, as they go around the joints, it may be zoomed in a little bit too far, and cracks or joint gaps may look a lot bigger than they really are. And similarly, when they get to the top of the pipe, if the camera is too low in the pipe, as they get to the top, it may look like it's too that the crack isn't an issue when maybe it would be, or maybe the joint gap isn't an issue when maybe it's a little bit bigger than it really appears on the camera. So if it's centered in the pipe, then we know that we can get a really good reading on these, and we can get a good idea of what's happening. Another issue that I see with these is we want to make sure that it's slow enough to see any potential issues with the pipe. I've seen videos, I've watched pipe videos where these cameras just zip right through. And that's not a good practice when we want to review these, because I want to see the issues. NASCO recommends no faster than 30 feet per minute. So that's how long it should take you to go through these pipes. 30 feet per minute is the minimum time. So you could always go slower, but that's what NASCO recommends. Okay. I always recommend that they stop and document any cracks or damages. So if you're going through and you see a crack as you're going through, that they stop, they notify, they document it, they mark it on the screen, they code it correctly so that we could come back and review that. They put it in the report, everything. Another recommendation is that you get full circumference at all of the joints. You want them to go through the entire joint so that we can look and see, is there any issues with that joint? Is the gasket in place? Is the joint too large? Does it exceed manufacturer's recommendations? Those are certain things that we want to look at these joints and make sure that it's done correctly. Now, one of the notes that I found interesting was in the Utah APWA specification. It says zoom where necessary. So one thing that we always get nervous about is when a operator, as they're going through and videoing these lines, they see an issue and they zoom way in. And now all of a sudden a crack that might have been hairline looks really, really big. And it arouses suspicion and concern, and all these people say, oh no, that looks so bad, we've got to remove that. And that's not always the case. And so if we're zooming in only where necessary, that's good. But we've got to be really careful when they zoom in, because some of these smaller diameter, 12, 15, 18-inch pipe, the more you zoom in, the larger these issues are going to look. So be very careful and leery when we're zooming in on CCTV. Now, with reinforced concrete pipe, what we're looking for cracks, obviously, as we've been talking about. We're looking for joint gaps and maybe exposed gaskets. Are the gaskets in place? Are they exposed? Are they in the joint itself? Those are things that we're looking at the joints. We're looking for any damage. Whether a pipe was damaged during construction, if it was hit, if they loaded it too much. We're just looking for any damage where something's happening that it shouldn't be. We're looking for any obstructions, anything that was maybe in the pipe. I've seen pipe videos where someone came in and punched a hole through it to put either a comm line or a gas line or something through it. So I've seen pictures or videos of pipes where they've had obstructions going through it. I've seen pipes where they've driven the barriers up above, where they're driving the stakes down into it, and it goes into the pipe itself and causes some damage and some obstructions. That obstruction may be debris or any issues that could cause, affect the function of the pipe, where if there's debris in it, construction debris or different things that's stopping the water from flowing correctly, that could be a problem as well. So we're looking for that. We're also looking for any sags in the pipe, any bellies, anything where it wasn't installed on grade, or if there's any issues that way. So here's a couple of pictures from some pipe videos that I've seen. This is one where you have an exposed gasket in the joint. So if you're going through and you're not stopping at every joint, you might miss this one. You might not notice that there's a joint or an exposed gasket in the joint. Now, when I look at this and I say, okay, is this going to affect the structure of the pipe? Probably not. It doesn't seem to have any structural issues in the pipe, but this could have an effect or an impact on the function of the pipe. It is possible that because of the way that this pipe is, or this joint is, this gasket, it's possible that it could still be sealed in there. This could just be one of the pockets of the pipe. If it's a self-lubricating gasket, the gasket could be coming in there. It's possible, but it's not probable. So in a case like this, there's probably additional repair that would need to be done to seal that. So an injection grout or some type of sealant in there, depending on the size of the pipe. If it's large enough, you can get in there with a non-shrink grout and seal it to make sure that it is serving the functional purpose of getting the water from point A to point B and not leaking. So if you see this in a pipe, there would be most likely additional repair necessary. This is one where these next two pictures are actually on the same pipe. This is at 28.1 feet of an 18-inch pipe. So this is the bottom of the pipe. So this would be at, if you're looking at the pipe straight on, this one is on the about 8 o'clock at the pipe, about 7 or 8 o'clock on the pipe. And this one here is at about 4 or 5 o'clock on the pipe. Okay, so it's basically the bottom of that pipe. Typically, this happens when a gasket wasn't equalized or it was loaded too much as they put it in. Maybe they put the gasket, it slipped and moved as they didn't put it in completely straight, so it wasn't homed correctly, and then it caused enough pressure and buildup in the bottom of the pipe as they were homing it that it just popped this bottom part of the pipe out. And so this could be a problem functionally. Structurally, it's actually a pretty minor crack. If you notice here, this stencil at the bottom of the pipe where it says 18-inch ASTM, this stencil is about an inch tall. So when you look at that crack, as it zoomed in here, you could tell it zoomed way in there. That crack looks huge, but now you scale back out and you go, well, this is an 18-inch pipe, and that stencil is only an inch tall. So that crack isn't nearly as big as we originally thought. It would probably heal itself over time. This is one that you may want to look at if it's causing problems, and you may want to observe it for a while, see if it'll heal. But at the end of the day, you could get in there and do some type of joint injection grout at the joint there and make sure that it's sealed so we're not leaking water. This is one where you actually start seeing a structural issue. So the previous ones were functional. This one would have a structural aspect to it. So this one, you could see the exposed steel, you could see the gasket. This is one that most likely was where the pipe was installed correctly and everything was fine. But after the fact, a contractor came in with a fully loaded construction truck and drove over it with the shallow cover and caused some significant structural damage to it. So in this case, this is one where we've seen issues where they've saw cutted the pipe and replaced just a section and poured a collar around it. We've seen grout sleeves used in this so that we could put that grout sleeve in so it provides a little bit more structural capacity for it, and then injection grouted it to seal it up. Those are options that we've seen done, but ultimately this one is going to have an impact on the structure of the pipe, so we need to look at some type of repair, whether it's a remove that section, replace it, or do some type of grout seal or structural lining to ensure that it's able to withstand those structural loads in the future. And this is another one that this one zoomed way in, so it's hard to tell what the width of that crack is, but this is one where you don't really have any exposed steel, but where it is a fracture, not just a crack, where you can actually see into the fracture there. This one could have an impact over time. Not sure how big it is because of how far it zoomed in. It could be 1/10 of an inch or less, so it might heal itself over time. This is one where you could look and observe it over a 6-month period, and during the stormy season when you have water in the crack, you could look and see, is this going to heal or not? You could observe it and see what's going to happen, and then go from there. And if you do need to, and this is one that would be a good candidate for an injection grout along the width of that joint, just to seal it up and make sure that the water isn't leaking and it's not causing any damage. It's not rusting out the steel in there. So that's a viable option for this one there. Okay, so some things to remember for reinforced concrete pipe. Repairs are possible. They could be costly for the contractor depending on what type of repairs they need to do. So we want to make sure that these contractors are taking care when they're installing this. But even though it's costly, they are still possible, right? We don't need to just rip up the whole pipe all the time. There are a lot of repairs that we can do before we get to the point of remove and replace. Mountain States Concrete Pipe Association, Oldcastle, TRE, that's me. These are good resources if you have any questions on what you should do, on what recommendations we have on repairs and different things. I would be a great resource. Mountain States has good literature that we can refer you to look at what some of the recommendations are on the national specs and different things. But those are good resources if you have any questions on that. And at the end of the day, we want a good installation, right? We want to make sure that your installation is going to last. Our product, we hang our hats on that a lot on longevity and the strength and reliability of concrete pipe. And so we want to make sure that we're getting a good installation. And so hopefully we'll never recommend any repairs or anything that would jeopardize the long-term life of the pipe, because that is our main selling point of our product, and we want to make sure that our product is being used correctly. Okay. So with flexible pipe, what are we looking for? Well, we're also looking for cracks and joint gaps, and these are a little bit more critical with flexible pipe because, as we know, we're building that structure around the pipe, and if we have any cracks or joint gaps, and that material that we built, and compacted around to create the structure, if it is undermined in any way with a joint gap or the materials coming into the pipe through a crack or joint gap, that could mean major issues on the structural stability of the pipe. So we want to look for cracks and joint gaps as well. We're looking for any damage like buckling or crazing. Crazing is where over time plastic, if it's bent too much, if it keeps bending, it gets weaker and weaker over time, and then it eventually will fail. Any obstructions, just like with concrete pipe, if there's any obstructions, any construction debris in there, anything penetrating into the pipe from the outside, any tree roots or any rocks or anything like that would be a big deal as well that we want to look for, and any sags. So these are things that, as we look on these, right, all of these things we're looking for. These are things that we need to look at in a CCTV camera, right? Again, we are going to check for deflection, but any non-elliptical deflection, that's something that we can notice in our CCTV inspection as well. So while some people may say, well, for plastic pipe, we're only going to do mandrel testing, we're only going to do deflection testing, some of these things you're not going to be able to tell. Cracks, joint gaps, any damage or things to the pipe, those you're not going to be able to tell just by pulling a mandrel through. So you really need to do both CCTV and mandrel testing or deflection testing for that. So this is a picture of non-elliptical deflection. You can see that it's got some deflection on the right-hand side, but on the left-hand side, you've got this kind of straight deflection there. So instead of deflecting in an elliptical fashion, this is a non-elliptical deflection. Okay. This picture shows some buckling on the top where it's been overloaded. It's not just an obstruction coming through the pipe. This one is actually, over time, it's been loaded too much. You could see on the right-hand side, there's kind of that whitish film there on the side. That is actually from crazing. Over time, as that plastic gets weaker and weaker, it's because it's bending, it's going to become weaker, and it's ultimately going to collapse. So that's an issue as well. This is one where something had obstructed it. So you had like a big rock or something that came through and was pushed into there. So this is an obstruction that pushed into the pipe and caused some pretty significant buckling and damage there. So when we talk about mandrel testing or deflection testing, these are two examples of mandrels that you could pull through. They've got 9 fins on them. You attach them to a rope. You use a roller guide on the sides of the manholes. You have an entry and an exit, and you're basically pulling this through by hand. The mandrel itself is set to whatever diameter the pipe is to the allowable deflection. So if it's 5%, then a 24-inch pipe would be set to 24-inch pipe minus 1.2 inches. So it'd be set to 22.8 inches, and you pull it through the pipe. If it makes it all the way through by being able to pull by hand, you don't want to attach this to a mechanical machinery to pull it through, because that'll go right through a plastic pipe just like butter. But if you pull it by hand and it gets stuck, we know that it doesn't meet the deflection, and that section of pipe needs to be removed and replaced. So that's the most efficient way, and that's the best way that I've seen it done here locally. On smaller diameters, on large diameters, you can go in and just spot measure every so often and check and make sure that the deflection meets the minimum requirements there. Now, something that's new to deflection testing is laser profiling. So this is something that is being done in other places in the country. I haven't seen it much in Utah and Idaho. Hopefully, eventually this comes here, and it's something that we could provide, or we could see being provided to contractors and to municipalities to ensure that these things are being built correctly. But this is a really interesting and fascinating thing here. So this is kind of how it works. When you have your CCTV camera and your remote control camera there, they put this laser on the end of out on an arm that extends out past the camera. And what it does is it spins a laser around, and it spins very, very fast. So what it looks like in the camera is it looks like there's a red circle around as you're going through, because it's spinning so fast. All right. And so what the output shows, and I've got one that has 4 different ones here. The green circle is true round. So you could see what a true round on the circle would look like, or a true round pipe would look like. And then the red shows what it actually looks like. Now you may say, well, why is it flat on the bottom there? Is it deflected on the bottom? No, that's because there was some water in the bottom of the pipe. So obviously as it spins on there, any flat surface is going to show up as flat. So we're really looking at the sides and the top. How much deflection are we having, if any? And it looks like on all of these here, on these examples that we've got here, every one of them is seeing some level of deflection. And in fact, as you measure that, you would note that all 4 of those are outside of the acceptable 5% of deflection. So this is just an example of what laser profiling can do. So instead of having to pull a mandrel and do CCTV, you can actually do both. You darken the line, you run the laser through, and then you lighten it, and then you run the camera back through, and you can do it all in one take. So you can just go down and back, and down with the camera, back with the laser, or however you want to do it. So that's a great option that we can do. I've got a video that I want to share of this laser profiling, so that you can kind of see what it looks like in a video. And so I'll play that now. So obviously there was an issue with this pipe, and after getting to the end of the line, they went back with their light and camera, and they saw what the issue was. Now, this is an image from the video that shows the top of the pipe smashed by something. Now, in this case, there was a large boulder in the backfill material, and as they were compacting above the pipe, this large rock damaged the plastic pipe and came through and punctured it. So this is yet another reason to follow the specifications and make sure that there is an inspector on site during construction to make sure these types of things don't happen. So just a few things to remember when dealing with flexible pipe. Keep in mind that if a pipe does not meet the minimum deflection requirements, the only acceptable repair is to remove the pipe and replace it with a new section of pipe. Now, typically, these pipes are under a paved roadway, as we talked about earlier, so this can be very costly and time-consuming for the project. Now, anytime we have pipes going in the ground, we want a good installation because we want the products to last so that owners can have a good return on their investment. And a great way to encourage best practices by the contractor during installation is to require post-installation inspection on all pipe installation projects. Now, I want to thank everyone for taking the time to watch this webinar today. We were able to provide a very high-level review of rigid and flexible pipe installation. If you would like more detailed information about the differences between rigid and flexible pipe as they relate to design and installation, feel free to go back and watch some of our other webinars on the Concrete Pipe Guy YouTube channel. We also discussed cracks for rigid pipe and deflection for flexible pipe, and which cracks and deflection are acceptable and why they are acceptable. And lastly, we discussed the importance of providing post-installation inspection and recommended some best practice associated with the PII. For more information about this topic or any Oldcastle products discussed in this presentation, please email me at jason.allen@oldcastle.com or visit oldcastleinfrastructure.com.